Great, thank you. So hi everyone, can you hear me okay? Good. So my name's Nora. I'm a senior chaos engineer at Netflix. I've been working at Netflix for about 24 hours now, and it's gone great so far. I haven't managed to cause any massive chaos yet, but hopefully I will soon. So since I haven't done much yet at Netflix, I'm going to talk to you all about how I introduced chaos at my previous company, Jet.com. For those of you not familiar with what Jet.com is, it's an e-commerce site that was launched in July of 2015. Jet's motto is to save you money on the things that you already buy by buying in bulk. I started working there in September of 2015, just 2 months after Jet launched, so it was still very much a startup at that time. Jet scaled extremely quickly. Within months, they had over 20K orders per day. They had featured apps in the Apple and Android stores and over 15 million SKUs in production. SRE and internal tooling efforts were very much needed, and they were needed quickly. At Jet, I served as what's known as a software productivity engineer, and I realize that's not a common term in a lot of organizations, so I'll go ahead and explain what that is. Software productivity engineering at Jet encompassed 4 different umbrellas. There was fault injection, which is chaos engineering, risk engineering, efficiency engineering, internal tooling and monitoring, and some performance engineering as well. It was just me on the team for about 7 months. But by the time I left, we had multiplied the team by 5 by gaining 4 more people. So as I mentioned, I'm going to talk to you all about how I started chaos at my previous company and sort of take you on this journey with me. But in order for us to properly start this journey together, it's important to know the product and to know what chaos testing actually is. So starting chaos. So what is chaos engineering? Chaos engineering, from the Principles of Chaos website, is the discipline of experimenting on a distributed system in production in order to build confidence in the system's capability to withstand turbulent conditions in production. So what does that all mean exactly? It's essentially making things happen that are bound to happen anyway, making natural disasters automatically happen to make our services more resilient. I've seen metaphors in the past, metaphors for like a flu shot, right? Like you give yourself a flu shot every year to make yourself more resilient to the flu, but what you're actually doing is injecting the flu into your body. You're injecting some failure into your body, and so that's what we're kind of doing with systems too. So like I said before, in order to successfully run a chaos initiative in your company, you need to understand the fundamental business goals of your product and have a high-level view of the technology that runs it. There are several different levels of chaos that I recommend introducing before unleashing a full-blown chaos solution. And I'll go through each of the levels and evaluate how the chaos tool has influenced the process and leave you all with a game plan of how you can culturally and technically introduce fault injection in your organization. So interestingly enough, my first project at Jet was actually a chaos engineering project, which is a very unique way to start at a company. You know, it gives you a full lay of the land. It allows you to meet people, but you know, you have to approach it very carefully. At Jet, we had started chaos at the time due to a site outage that caused the site to be down for almost an entire day over a weekend period. So my manager at the time had come up to me and said, "Okay, this could have easily been caught if we had chaos testing in place. Like, can you get started on it?" But I had just started at Jet, so I said, "Yeah, sure. You know, what does the system look like now? Do we have any documentation on it?" And for those of you that have worked at startups in the past, or just any distributed systems, you know the documentation is rare, and it's hard to keep up with, right? So nothing existed at that time. Jet had just launched 2 months previously. You know, there was nothing there. And so I was at a point in time at the company when I didn't even know who to talk to get information. So I started, running around asking people, trying to find different pieces of information to decide what the normal state of the system looked like. And so I eventually realized that most of the system lived in the heads of the 3 engineers that had started at the company. So I got most of my information from them. So to start out, Jet has a microservices-based architecture. And Jet actually has a ton of microservices. When I started, there was over 700, and when I left, there was over 900. And I'll get into more later why they had so many microservices, but Jet's architecture was naturally chaotic without even introducing chaos engineering. I mean, with 900 microservices, you know, stuff is just flying everywhere. This is an actual Oprah episode. It never aired, but yeah, with so many microservices, you know, there's so much going on all the time. And Jet's tech stack actually had a little bit of everything in it. So I think it's important to understand the tech stack a little bit too before you get into chaos testing something. I mean, there's generic chaos testing you can do, but in order to actually be effective, you should really understand at a high level, you know, what your tech looks like. So this is some of Jet's tech. Jet used Azure, not AWS, for probably obvious reasons, that being that Jet is also an e-commerce site. They're very much a right tool for the right job kind of company, but with so much going on, it's natural that you forget about things that are running on their own. Some middleware they used was Console Kafka, Redis, Splunk for monitoring, heavy users of fsharp on the back end. I would say almost 90% of microservices were written actually in fsharp. R and Python for data science needs, Azure Blob Storage, SQL Azure, and React Node and Angular on the front end. So again, with so much going on, like, you naturally forget. But I'm going to zoom in on this particular point, fsharp here, because not a lot of companies use it, and a lot of Jet's architecture is written in it. So, you know, as someone that's chaosing the system, you should probably understand how that works a little bit. And I actually decided to write my chaos tool in fsharp as well. So I'll go into why fsharp really quickly, just because I know it's not a common use. Fsharp is functional first. Functions should not have more than one reason to change. It's simplistic, type inference, no curly braces. It's concise, and it actually is really easy to learn. I think functional programming languages get a bad stigma attached with them, that they're difficult to learn and you have to have a heavy math background to learn them. But it actually was really easy to pick up. Also, it was .NET based, and a lot of Jet's early engineers were .NET folks. So a microservices architecture so naturally arrived due to point number one, and which heavily related to the single responsibility principles. In truth, I think you can have successes with any language so long as you keep up with good engineering principles. However, with functional languages like fsharp or Erlang, it can be modeled like a functional process. So what do I mean by the single responsibility principle? A service that follows the single responsibility principle performs a single business function or system function. So if you think of an e-commerce site, you know, we might want to send a user an email when their order has shipped. So a microservice might be modeled like this. You know, you send an order shipment email, it sends an email, and it notifies the email sent. That's it. Your microservice is that small. And so Jet was heavy, you know, we heavily practiced this at Jet to abide by these single responsibility principles. And so most of your services were actually only 300 lines of code. Usually a lot less than that, which is why, you know, they ended up with so many microservices. The benefits of that are kind of obvious from the beginning, you know, scalability, distribution of complexity, and independent releases. However, there's some drawbacks as well, you know, latency, difficult to troubleshoot. So I think this one could, sometimes it was actually really easy to troubleshoot, sometimes it was difficult. You know, it was easy in the fact the popular microservices that were actively worked on, you knew exactly what they did. So if there was an issue in them, you could go debug it automatically. However, the ones that not everyone worked on all the time, you know, the other 700, you know, they were difficult to troubleshoot if something went wrong, and also increased management overhead. So single responsibility principle in functional programming, a function always creates the same output for the same arguments. And for functional programming fans, this is called referential transparency. So now that we have a background on this product that we're chaos testing and we have a high-level view of what the tech looks like, let's start introducing some chaos. So we'll begin with level one. So level one is graceful restarts and socialization. But before I get into this, is anyone here a PC gamer? Anyone play Warhammer or Total War Warhammer? Cool, a few people in there. So this is a true story. I was in the library working on this presentation, and someone was playing PC games in the library without headphones on, and they were playing Warhammer. And I kept hearing this notification going, "The armies of chaos are coming, prepare your defenses well," as I was preparing a presentation on chaos engineering. And he just keeps saying it over and over again, "The armies of chaos are coming, prepare your defenses." And it's getting a little annoying, but I started laughing. I'm like, this relates to what I'm doing so much. When you introduce chaos at an organization, like, do you let people know that your armies of chaos are coming, right? Do you notify them? How much notification do you give? How much is worth it without it being annoying? So I actually walked over to this person. I tried to Google it, and I couldn't find any good notification, and I took a picture of his computer with my cell phone, so that's why it's so low res here, but it says, "Prepare your defenses well for the forces of chaos, spare no one in their quest for bloodshed." So I thought that was awesome and super ironic. So yeah, this notification pops up every 30 seconds letting you know this. And while I recommend some level of cadence, this much notification can totally be annoying to your teams. You don't want to notify them all the time, "Hey, we're doing chaos testing today." You definitely want your developers in the know. It's not meant to surprise them. And it's good to keep in mind that the word chaos sounds really, really cool to SREs and cool to chaos engineers, but it does sound scary at times to people that are product devs and PMs and managers that might have never heard of it before. So as I mentioned before, my first project at Jet was actually chaos engineering. We started chaos due to a site outage that caused the site to be down for almost an entire day over a weekend period. It was something that could easily have been solved doing chaos testing. So level 1, I decided to start off small with graceful restarts using a predefined set of services. In order to select that predefined set of services, I just took all the services that were in Jet, and I told teams, "Hey, let me know if any of these services is ineligible for chaos testing." I also decided to start in QA. So I met with some teams. I got a list of some services that were ineligible for testing. And then I also sent an email asking which services were okay to chaos, and not all teams responded. And it got to be a few weeks later, and I eventually just assumed that it was good to go. So how do we define that we're ready, right? And since there was very little information given about this, the results were telling. So while working on chaos testing at a company is a quick way to meet your new colleagues, it's not a great way. I definitely met everyone within those 2 weeks. So I was very, I was very well known, maybe not for good reasons at first, but I definitely wouldn't recommend starting off with a chaos engineering project as a way to meet your colleagues. I promise I did not leave the company in this state, though. There were not torches being thrown at me. While engineers didn't exactly welcome this at first, in addition to their normal on-call rotations, they eventually adapted to it over time. So this brings me to my next point, socialization, and how important this is with chaos testing. It was a lot harder to socialize and get acceptance of chaos than it was to actually implement it and develop it. Dissemination of information was something that needed to go through a lot of trial and error. And it's not some formula that you can just bring to every company. Like, every company is going to be a little different. Every culture is going to be a little bit different. So you kind of have to get a lay of the land first and see, what works and what doesn't. But there are certain things that, I definitely recommend. People in software, and especially software engineers, naturally like to be in the know and have control, and chaos kind of disputes that point. So as chaos engineers and as people that are developing internal tooling and as SREs, a lot of our jobs are not just development, but they're also socialization and understanding the customer and their needs. And in your case, the customers are your colleagues, they're your fellow engineers. So at Jet and for many companies I've heard from, there's no mandate in place to force a team to be chaos or to force them to use a tool, which I actually appreciate. I think it keeps people happy. But it was important for me to be able to empathetically explain to teams why it was in their best interest to be chaos and to participate in this. So a lot of this involved me educating them on what exactly I was doing and what exactly it meant for them. Part of this is actually relating chaos to automated testing that's in place, to SLAs, and to ultimately the customer experience, which brings me to my next point, which is monitoring. So monitoring and controlling the chaos. So this is a sample screen of monitoring that teams could actually use to view what was going on in chaos that day. We use Splunk to give information to folks about chaos. And so as you can see in this chart here, this actually allows the chaos team itself to see how many restarts they're causing per day. And if there's a spike, like the example August 22nd, you can know as a chaos team, like, hey, maybe we're chaosing too hard this day. Like maybe we should set some SLAs for ourselves and take it back a little bit. And then down here, you can actually see the restart. So you can see the time it was restarted. You can see the cloud service. You can see the instance name associated with that cloud service. And something that's really important is you can see the deployment that's associated with this cloud service. So you can actually associate, bad or faulty deployments to when chaos testing actually causes your service to have errors. So that proved to be really useful as well. Something that we as a chaos team also did was filter it based on team as well. So we weren't throttling the teams too much at once. So in order to do that properly, we needed to have proper naming conventions, right? So Jet had superhero names. So we would associate the cloud service based on that superhero name, and then they owned a bunch of services within their superhero. So in order to do that correctly, in order to make sure we weren't throttling that service, we had to make sure things were spelled correctly. We had to make sure people were using proper naming conventions. And we ran into things a few times where something was just misspelled, right? And so it ended up getting chaosed so much just because it was misspelled. We also allow colleagues to whitelist their services for various reasons. If they were debugging a previous issue caused, if they were having a super major deployment, et cetera. However, every time they wanted to whitelist their services, they actually had to submit a pull request. And in that pull request, they had to include a JIRA or TFS ticket explaining the fix on why they needed to whitelist their services. And it would automatically only last a sprint. And if they needed it to last further, they would have to come talk to the chaos team. In parallel, we also ran UI automated tests and performance tests against our deployments. And we eventually started correlating chaos restarts to issues that we were seeing within our automated UI tests. We also decided to run the chaos only from Monday through Friday, 9 to 5, so that we weren't adding to engineers' on-call rotations. And then additionally, we decided to start it in QA. So, again, it's important to get the lay of the land at a company and important to understand the culture. And something that I started understanding about the culture at Jet was that they were heavy users of Slack. So I made use of this. I alerted when something got chaos, or I alerted when a machine turned off, and I had Slack bots that let it be known. And like I was saying before, Jet was superhero themed, so we had a little fun with it too. There was an incredible service, and put a little fun comment in there. There was a shield service. So this was actually all one team services. And so this was a learning experience for me being on the chaos team, in that we were hitting this team way too much in a short period of time. And it was actually due to a misspelling that I mentioned earlier, and due to not using proper naming conventions. So once teams actually started putting their team name within every service, it allowed for us to manage this better, and it allowed for us to better chaos their services. So this brings me to level 2. Other than socialization's efforts that we needed to go through, chaos testing was going pretty well, and we started to get excited. I thought, if we know at a high level what is talking to each other, can we predict when a cascading failure is about to happen? So we met with a few teams. It was a big cross-team functional effort to decide what we thought might be a cascading failure. So we tried to cause one. Cascading failures are when a small fault in one component triggers a fault in another component, which in turn triggers further faults. And the bugs that cause these kinds of software faults often lie dormant for a long time until they're triggered by an unusual set of circumstances. In those circumstances, it's revealed that software is making some kind of assumption about its environment. And while this assumption is usually true, it eventually stops being true for some reason. So, we got all ready to cause this cascading failure. And we did do it. We did cause a cascading failure, but we did not cause the one we anticipated. So big surprise, right? Big surprise to everyone that's worked in operations before, but not really that much of a surprise. So all of a sudden, like, search wasn't resulting in data anymore, and pricing started seeing all these timeouts, and then search wasn't handling these pricing timeouts, and then this eventually led to the realization that Elasticsearch was completely down in QA. I just want to preface it. And it actually brought QA down for an entire week due to causing this cascading failure. So it caused a lot of problems in regards to delay deployments, fixing tech debt, pushing back features. Chaos engineering was not exactly being received well at this point because we took QA down and caused all these issues. And I knew I needed to start socializing it a little bit smarter. I actually had a few PMs ask me at one point if I could turn off chaos during releases. And Jet released multiple times a day, every day. And I was like, okay, they're not understanding. I need to do something better here, right? I need to explain this better because this is actually a form of testing. This is actually making sure your deployment is going to go well. So I needed to understand my customers and their concerns a little more. And in addition, I had to explain what I was actually doing. No, I did not take QA down, but the chaos tool did. You know, I think at first people were picturing me like maniacally sitting at my computer pressing buttons to take like Elasticsearch down, which wasn't the case. You know, it was a tool that was automatically running that was doing it. And I needed to explain that chaos was helping us build confidence in the fault that would be handled correctly when they did occur naturally. So I could show some diagrams here, but the simplicity of the code actually allows you to understand what this is doing without having a background in F# itself. And this is actually in an article on the Jet Tech blog too, if anyone's interested in looking at it later. So we'll learn some F# today. You know, I don't think there's enough code in some of these conferences, so we can dig into this a little bit too. It'll be fun. So for a chaos service within the handle function, we call out to a few different functions. So we get the hosted service details from Azure. We get the service name. We get the deployment details. And then we get all the role instances. We pipe that sequence so that character there after let instance is called a pipe. And so we pipe into sequence to array, and then we do a random pick. And my random pick here is actually a Nth shuffle or a Fisher-Yates shuffle, which ensures a random permutation. And this is really important here to ensure that we're actually uniformly randomly picking these services so that one doesn't get throttled too much. The compute here at the top is a compute management client that allows us to work with the Azure management setup. And we're logging all these details as well. So this is my restart random instance function. We use pattern matching here to see what the status of the node is. So if a node is in a bad state, if it's stopped, if there's erroring, we don't restart it, right? We're not that mean to cause further issues, but we do alert the teams like, hey, your node is in a bad state, you should check this out. Additionally, which is not in the code right now, is we also check for if only one node exists, right? We won't take down the whole service if only one node exists because that could cause a lot of problems. But we do alert teams automatically and give them a certain window of time to fix that or a certain reason to state why only one node exists. And then the underscore there means every other case, so that means essentially restart the instance. So here's our compute function. A lot of the magic is here. It's essentially one long piping section. So we get the computed details. We get the ignore list. So that was that whitelist I talked about earlier, where teams could submit a pull request and we'll get the whitelist of all the services that they don't want included in chaos testing. And then we do our Fisher-Yates shuffle. And then we pipe it into an async parallel ignore, which is really interesting. It doesn't keep track of the asyncs that comes back, and it actually allows us to keep a bound on the parallelism. It starts the computation actually on the calling thread, which is really generally faster. So something that I also put together was a demo, this skeleton failure injection library, which actually will allow you to chaos test your code on a functional level. I wrote it in F#. It's meant to work with functions itself and actually chaos testing functions and code. And it blurs the line a little bit on static analysis versus chaos engineering, but in my mind, it's still chaos. So I'm going to show you a sample public library on how it works. That is not big, is it? Is that better? Okay. So so this is, oops. Sorry, 1 minute. So this is a skeleton failure injection library. All right, it's not seeming to cooperate with me right now, so I will just explain it to you. The link is public, though. My GitHub name is Nora Jones, and the library is called Skeleton Failure Injection Library. So it supports the ability to inject a delay or an error in a simple API for the library, which demonstrates its use. The library is defined in the chaos.fs file, and the chaos module contains within this file defines our main chaos injection. So let's see. So the name here actually means the name of the type of the chaos that we're injecting. Should chaos is a Boolean, so teams can actually control whether or not they want to turn this chaos on. In addition, you could actually turn this into a config file, and you could allow people to say true or false for different types of chaos if they're relevant to them. And then the chaos async unit. So the two examples I did here were fail with exception, which raises a random exception, and introduce latency, which essentially just puts an async sleep in there for a predefined set of milliseconds. It's important to set the criteria here as well. Like if you only want chaos to happen on a certain period of time, or if you only want chaos to happen on certain criteria, that's something we can do as well. So in this case, the criteria here was if the date time now was 0, then this chaos would run. Or maybe you want it to be only during business hours that this chaos actually gets injected on the code. So here's an example. We do a chaos exception on a simple time-based failure. We throw a random out-of-memory exception here. And then here's another one where we're actually piping the function into a simple time-based latency exception where we run it for 5,000 milliseconds. So it's still important to test your test code as well. So making sure that if we always want to chaos, that's true, or if we always want to run latency, that's true as well. So that's just a short demo. Most of the information on that file is in the README if you're interested. So let's go to level 3, which is targeted chaos. So chaos testing in Azure and AWS services is great, but we noticed that a lot of our problems in prod were occurring from problems with our reliance on middleware, like Elasticsearch and Redis and Event Store and Kafka. So how do we include those in chaos as well? At the time, Jet had just experienced an outage with Kafka, and so we decided to start there. I totally recommend when you're doing chaos, starting with something that's already happened. It's a lot easier to gain buy-in when you're recreating an issue that's occurred in production. So some of the problems with chaos, or some of the problems with Kafka are monitoring. So to give a background on Kafka, Kafka is a message queue with database-like durability guarantees, and it's a publish, subscribe, distributed messaging system. There's no full-feature time series database right out of the box, and you'll have few key metrics that are broker-specific. What if the offsets of the broker start becoming incorrect? How do you deal with that? How do you know what caused the offsets to be incorrect? What happens if you get a bunch of consumers listening to one topic at the same time? You're placing a lot of load on that topic. Like, could you get an uncharacteristically high read level? What if tens of consumers are listening to that topic, or hundreds? So we started coming up with ideas. And this was a big cross-team effort, too. So it got a lot of people excited about chaos, and it got a lot of teams working together as well, which was really nice. So some suggested changes were force killing any service that we want through Ansible, through a playbook in Ansible, maybe targeting one particular host, maybe deleting a topic entirely and seeing how things recover from there? Or what if we do partial deletion, but different on each node? The ones that aren't redundantly replicated and the ones that are. What if I delete a segment? What's the data loss there? What if I delete random segments on a smaller cluster rather than just pull random nodes out altogether? So killing brokers is easy, and it also usually takes a long time to recover on larger nodes. We could look at network traffic, shoving IP rules in a table on Kafka, blocking certain subnet rules on Kafka, adding a delay or random packet drops, stressing that one or all of the brokers with a ton of load on something, or several topics could end up losing their checkpoints. What if a topic loses their checkpoint, then what? Or we could look at CPU usage. We could starve Kafka and start a bunch of high priority things on the system. It's also important to coordinate with your infrastructure team on this if you're not directly working on that. You may want to add more machines in this case, or the network will be a bottleneck for a lot of the issues. So the reason I'm bringing this up is, you're going to have things at your companies that you maybe aren't directly controlling. So it's important as a chaos engineer to actually understand how that thing works. I had to deeply understand how Kafka worked and deeply understand how all the ways that it might fail. And a lot of that involves working with teams and understanding, how they're using it and coming up with ways to fail from there. So we didn't get very far into level 3 before we started seeing some actual chaos. Chaos rebooted a broker, and it did not help our debugging efforts much. So teams automatically have the capability to whitelist services they need to debug through the ticket which generates the PR. So so this was just an example of the results of targeted chaos. So this brings me to my next point, which is kind of an optional point. Gamifying the process. So I went to a really interesting talk yesterday about gamifying operational excellence, which was really cool, and it was about how LinkedIn gamifies their whole ops process, and they get really into it. And so I started thinking here, could we make the process more fun at Jet? Could we make chaos testing and distributed systems testing more fun? Could we get people actually excited about seeing breaking points of their services and building more resilient systems? There was a competitive spirit at Jet that actually enjoyed this certain thing. However, watching Daniel Lawrence's talk on gamifying operational excellence yesterday got me thinking about which type of cultures this would be okay in. I think it's definitely important you have a good lay of the land before introducing sort of a competition, right? I wouldn't recommend introducing this as your first form of chaos, gamifying the process. I was also, I was bringing this up to someone before, and Jet was on the East Coast, and they were saying that, this wouldn't fly on the West Coast, doing games like this. And I'm curious on people's opinions about that. So if anyone wants to talk afterwards about that, but there was a certain competitive spirit that actually made this fun. And so I had a feeling that it would go over well after working with Jet for a certain period of time. So one of the most exciting and nerve-wracking times of the year for an e-commerce company is Black Friday, or as Jet liked to call it, Purple Friday. So the Chaos team decided to start introducing the Purple Friday games. So we had a point-based system for the Purple Friday games. We worked with data science teams to set approved goals on what the predicted amount of traffic was for the year. However, when you're a new company, you don't have a lot of historical data to work off of, right? We only had a year of historical data, and last year's data was right after we launched, so there was a lot more to be expected at this point. So there wasn't hard and fast rules for running these games or deciding the load that was going to be on the systems, but so we had to think about this very carefully. So we worked with teams to set goals. We worked with teams and managers to set goals, and they had to go through an approval process. And we ran these games for 2 weeks. So if the team reached their approved goal, they got 200 points. If they reached their goal in the quickest amount of time, they got 50 points. We included load and performance tests in these as well. We wanted teams to be running these on a regular basis. We wanted teams to be introducing their own chaos and their own performance tests. If they were able to meet their performance SLAs in an emergency situation, for example, a sudden outage that maybe the chaos team would cause, they would get additional points for that too. But we also had to start thinking about service tiers because this might not be fair to every team, right? Like every service tier is a little different. So at Jet, tier 1 meant a customer-facing service. Tier 2 meant a back-end service that, wasn't directly affecting the customer, but the engineers were having a bad time. And tier 3 was kind of supporting services. So we graded all the tiers a little bit differently, and we allowed the tiers to compete against each other. And if a team was suggesting load or stress tests or chaos tests to us and coming up with their own, that was a lot of additional points as well. So the dashboard looked something like this. We allowed teams to see the progress toward their goals. So Jet was set up in an open office environment. We had 4 different quads, and I put monitors in every quad, and on those monitors was a selected dashboard where you could see the associated teams that were competing with each other. So you could see all the progress towards their goals. You could see how they were doing against other teams. You could see the total points across all the superheroes and today's later. So this is just a mock-up of what it looked like. But people did get really into it. We had a very small team at the time, and so we had to run a lot of maintenance on this dashboard too to make sure it was working at all times. So make sure that you have that in place first before you introduce these games, because people might actually get very into it. So level 5, what other uses can our chaos tools have? There's a lot that it's doing. Is it just meant for chaos? So this is sort of an optional level, but we were getting creative here. We were turning machines on and off automatically and causing chaos in other forms as well. But could we do it for anything else? We decided to look into chaos-based cost savings, which might seem minor at first, but over time it actually added up. So essentially we used the functions in chaos that we already had. We used the code that we already had, and we created a public README for everyone at the company to go to. And in that README in a shared repo, where actually it was a text file. So in that text file in a shared repo, teams could go in and they could add their services that they wanted to be shut off overnight, which was actually great for dev and QA. You don't need dev and QA machines running all the time. You can actually scale back some of them too, and those would be turned off automatically overnight. So we had to set a few precedents first, like these machines had to have a static IP address. And if they didn't have a static IP address, they needed to be okay with losing their deployment history potentially. So on a monthly basis, this could actually save thousands of dollars if rolled out correctly. These machines opted in would automatically shut down at 7 p.m. every night and then would get started back up at 8 p.m. And then on weekends, these machines would be empirically turned off until Monday unless they were deliberately taken off the list. So the chaos tool would actually take that list down every night and turn off those machines or turn them off for the weekend. We understood that this might not work for everyone's use case. So what if taking down your whole service, you wanted to just scale it down for certain hours, right? Like maybe you don't need it scaled up all the time. Auto scaling could work somewhat in this regard, but we definitely wanted to get a little bit more specific with it. So how the chaos tool has influenced the process. I genuinely think the true mark of an accepted tool at a company is when it starts influencing the development lifecycle and changes the way product devs and PMs go about implementation. So how the Jet tool influenced the process. Over time, teams started prepping for outages a little bit more. They were running chaos and dev as a test before deploying to QA. It led to a lot better documentation and understanding which services were talking to other services. There was stronger alerting and monitoring around outages and correlations between chaos team restarts on a service team level. And it actually led to the creation of a new team at Jet as well, a team that logs telemetry events and latency between sending and receiving messages. And those chaos team, my chaos team and that team were sister teams in that regard. It helped us plan for geo-replication by testing failover scenarios. And eventually, my favorite point was that teams asking for chaos testing advice and helping build it into their systems and wanting to chaos test as well. So actually wanting to work with the chaos team, asking for advice, and wanting to make sure their stuff was rolled out reasonably and well tested. That's it. Any questions? Thanks.
Hey, thanks for the talk, first of all. And I have two questions if I have time. One of them is you mentioned using and demoed a little bit about your own own homegrown tool.
Mm-hmm.
Did you look at other tools before making that decision?
So for Azure-based Chaos Monkey tooling, there was WasMonkey. It wasn't fully kept up to date, and it wasn't doing specifically what we wanted it to do. So I wanted to get a little bit more specific with it, and I eventually started writing it in fsharp, and then we eventually started creating our own solution that was really different. So I haven't looked at the WasMonkey code in a really long time. Maybe it's different now, but at the time we wanted to be a little bit more specific with it, and so it wasn't meeting our use cases then.
Cool. And I was also wondering, during the chaos testing, did you have what tools did you use to monitor the impact of the chaos test, right? Because you can run it and you can bring a server down and you can have an impact where your service isn't working properly, but then how do you know what it's actually doing, or how do you react to that and actually make your product better?
Definitely. It's super important. Otherwise, you're just causing chaos for no reason, right? So we use Splunk to monitor the logging, and we actually correlate those times to different things that are going on. So we'll have automated UI tests running. We had Jenkins deployments going. We had different other tests running as well, and we would correlate those times with chaos to those issues and those alerts happening. It could definitely be a little bit more sophisticated there, but we were at least able to tell, hey, this alert fired off right when chaos happened. Maybe it's causing that.
Okay, cool, thanks.
Yep. So at the company I work for, we're actually getting started to enter phase 1 where all the torches and pitchforks come out. How long realistically did it take to go from that point to where people put down their torches and pitchforks and actually embraced chaos testing?
So I'm assuming you know your coworkers, so you at least have a personal relationship with them. I did not know any of them at this point, so I was just some random stranger that was, messing up their whole week. So that's at least a good point, but I think it took a little bit longer for me in that regard. But you do have to spend a period of time, where, unless you have a project manager or program manager, but a period of time where you're not developing and you're actually meeting with teams to sort of educate them and to sort of understand any concerns they might have and to sort of tell them what you're doing. Especially the first use case, you want to be very transparent at first so that you don't mess anything up too much. And then over time, as you get more confident in it and as your teams get more okay with it, then you can start to introduce more chaos. But I think at first, just being super transparent goes a long way. But I would say for people to get comfortable with it, in my case, it took a couple months. We were doing well for a while, and then we had that setback with Elasticsearch, and then people started not getting okay with it again. But I remember actually getting pings from people like, we have a release today, and then later this afternoon, can you just turn off chaos for the next 2 weeks? And I was like, no, I can't do that. And that person that always asked me that actually ended up being the biggest fan of chaos when I left the company. He was the person that was sending me messages all the time. He was the person that was helping come up with ideas. So it was interesting to see his viewpoint and other people's viewpoints in the company shift over time. But I think a lot of it is just about, unknowns, right?
Great, thank you.
So if you have a distributed system with a good set of invariants, do you think that jumping to chaos testing is the first step or the last step? Meaning that, do you think fault injection and things that allow you to test the invariants very strictly first is a better approach? And did Jet jump to chaos because the set of invariants is just so large to be able to test given the number of microservices?
Yeah, it was very large. And we started because it was a suggestion from my manager. He noticed that if we had this simple chaos test in place, we could have actually prevented the site going down for an entire day over the weekend, right? And so that's why we got started with it. I always recommend recreating issues that are happening, right? If you can do that, I think that's the best way to start. But I think both of those approaches are good. You kind of just have to get a lay of the land first.
Hi. I have a question about the how do you defend yourself, like when your engineering team have issues with misbehaving software, misbehaving services? How do you defend your chaos team from getting blamed from the other teams?
So how do I defend my chaos team from getting blamed from the other teams when certain things happen? Yeah, that's a great question, right? And it happened a lot in the beginning, but I think, again, a lot of that is about education and saying, look, it's not us doing it. You know, we're giving you the opportunity to define the stuff that's okay for us to chaos test, and it's fair game at that point. You know, we're not actually causing issues. We're revealing issues that were already there, right? We're saving you from a bunch of headache by allowing you to actually deal with this during the workday when you're all here, and allowing you to deal with this before it turns into a bigger issue. So I think over time people actually started getting thankful, right, and not so much placing the blame.
I see. Thanks.
Mm-hmm. Great. Any other questions? Nope. All right. Thank you so much.